Max Desmond is a farmer who plants corn and wheat. In making planting decisions, he used the 1996 statistics at right from the United States Bureau of Census. Mr. Desmond wants to plant according to the following constraints: no more than 120 acres of corn and wheat, at least 20 and no more than 80 acres of corn, and at least 30 acres of wheat. How many acres of each crop should Mr. Desmond plant in order to maximize the revenue from its harvest? A method called linear programming is used to find optimal solutions such as the maximum revenue from Mr. Desmond's harvest. Linear programming problems have three following characteristics. The inequalities contained in the problems are called constraints. The solutions of the set of constraints are called feasible region, and the function to be maximized or minimized is called the objective function. For example 1, write a system of inequalities to represent the constraints, graph the feasible region, write an objective function for the revenue from Mr. Desmond's harvest. To solve for example 1, you will need to write a system of inequalities to represent the constraints, graph the feasible region, and write an objective function for the revenue from Mr. Desmond's harvest. And for x, let x represent the number of acres of corn, and let y represent the number of acres of wheat. And since x and y must both be positive, it will be x is greater than 0 and y is greater than 0. To represent the corn constraint, you would use 20 is less than or equal to x, and is less than or equal to 80. To represent the wheat constraint, you would use y is greater than or equal to 30. And for the total acreage, you will use x and y is less than or equal to 120. So the system of equations would be 20 is less than or equal to x and is less than or equal to 80, and y is greater than or equal to 30, and x plus y is less than or equal to 120. For B, the graph is shown like this, and to find C, the objective function for the revenue is as follows. R is equal to yield per acre times average price times X plus yield per acre times the average price times Y. And R would equal to 113.5 times 3.15 times X plus 35.8 times 4.45 times Y. And we'll simplify to R is equal to 357.525 X plus 159.31 Y. Corner point principle. In linear programming, the maximum and minimum values of the objective function each occur at one of the vertices of the feasible region. For example number 2, use the information in example 1, maximize the objective function, then graph the objective function that represents the maximum revenues along with the feasible region. First, you have to make a table containing the coordinates of the vertices of the feasible region, and for each ordered pair, evaluate the equation from example 1, which is R is equal to 357.525x plus 159.31y for each ordered pair. Once you have done that, you should see that the table is similar like this. And for the graph, you can see that the maximum revenue occurs at vertex C. To make the graph, you can see that the maximum value of 34,974.4 occurs at C, which is right here. Thus, Mr. Desmond should plant 80 acres of corn and 40 acres of wheat. And for the equation above, write the equation as y is equal to 974.4 minus 357.525x over 159.31. And then you can graph it along the boundaries of the feasible region. For example 3, find the maximum and minimum values, if they exist, of the objective function s is equal to 2x plus 3y, given the set of constraints provided at right. These are the set of constraints. And step 1, graph the feasible region as shown on the graph. Step 2, the objective function would be s is equal to 2x plus 3y. And step 3, find the coordinates of each vertex by solving for the appropriate system. When you solve for the appropriate system, it should give you something like this. And step 4, evaluate s is equal to 2x plus 3y for the coordinates of each vertex, like this. The feasible region is unbound on the right of the vertices, thus there is no maximum value. The minimum value, 28, of s is equal to 2x plus 3y occurs at 8, 4. 8, 4. To summarize the linear programming procedure, step 1, write a system of inequalities and graph the feasible region. Step 2, write the objective function to be maximized or minimized. Step 3, find the coordinates of the vertices of the feasible region. And step 4, evaluate the objective function for the coordinates of the vertices of the feasible region. Then identify the coordinates that give the required maximum or minimum. Parametric equations. A small airplane takes off from a field. 1 second after takeoff, the airplane is 120 feet down the runway and 13 feet above it. The plane's ascent continues at a constant rate. To analyze the position of the airplane as a function of time, you can represent the horizontal and vertical distances traveled in terms of a third variable, the time after takeoff. For example 1, graph the pair of parametric equations for -3 and is less than or equal to t and is less than or equal to 3. The system equations is x of t is equal to 2t minus 1 and y of t is equal to negative t plus 2. There are two methods into solving this problem. Method 1 is using graph paper. Make a table of values and graph each ordered pair x, y in the table and draw a line segment through the points graphed. Your table and graph should look something like this. And for method 2, you can use a graphics calculator. In parametric mode, enter the functions for x and for y in terms of t. Define your viewing window, including the minimum and maximum values for t, then graph. And your graph should look something like this on the calculator. For example 2, write the pair of parametric equations as a single equation in x and y. To solve this problem, there's also two methods. For method 1, solve either equation for t, x of t, and x of t is equal to 2t plus 4, and x is equal to 2t plus 4. So this x minus 4 over 2 is equal to t. And substitute the expression for t in any other equation and simplify. So y of t is equal to 5t minus 2. And then substitute t in, which is y is equal to 5 times x minus 4 over 2 minus 2. And then y is equal to 5 over 2x minus 10 minus 2, which is y is equal to 5 over 2x minus 12. For method 2, solve both equations for t. X of t is equal to 2t plus 4, which is just x is equal to 2t plus 4. And t would be equal to x minus 4 over 2. And y of t is equal to 5t minus 2, and y is equal to 5t minus 2. And y plus 2 over 5 will equal to t. And then set the resulting expressions for t to equal each other. X minus 4 over 2 is equal to y plus 2 over 5, which is 5 times x minus 4 is equal to 2 times y plus 2. And 5x minus 20 is equal to 2y plus 4. And y is equal to 5 over 2x minus 12. You can also graph functions and their inverses by using parametric equations. If f is a function containing the points x and y, x comma y, then its inverse contains the point y comma x. For example, f of x is equal to x squared can be represented by x1 of t is equal to t, and y1 of t is equal to t squared. The inverse of f of x is equal to x squared can be represented by x of 2 times x of 2